Hello guys, welcome to Spring Boot 0 to Infinity course. This is going to be our third video in this series. Previously, in the previous two videos we have already learned about what is framework, why framework, Spring ecosystem and the real world use cases. In the second video, we have learned about the Spring context and the beans and the different methods of creating the beans. So, what we are going to learn in today's video. In today's video, we are going to learn about the dependency injection and the different method of the dependency injection in the Spring. So, what we will learn? So, first, we will learn about what is dependency injection, what is dependency, and then what is dependency injection. Next, we will learn about different ways of dependency injection in Spring, like wiring versus auto wiring, different wiring and auto wiring techniques. Then we will learn about the common mistakes or pitfalls in the dependency injection, like circular dependency and how to avoid it, and how to choose the bean from the multiple dependency. So after this video, you will clearly understand how Spring inject the dependency and what is dependency and what is dependency injection, and how the Spring inject the dependency into our application. So let's start with very basics. First, we will learn about what is dependency. So dependency is nothing. When one class depends on another class for its work, then that other class is known as dependency. For example, if a class uses another class, that other class is known as its dependency. For example, here we can see that here is our car class, and the car class depend on the engine class for its working. So we can say that engine is the dependency of the car class. So we have car class and engine is the dependency of the car class. So here we can say that engine is the dependency of the car class. So what is dependency? Dependency is nothing. When one class depend on another class for its working, then that another class is known as its dependency. So here what happens? What is happening here? You can see that the car depend on the engine. We can say that here the object car depend on the engine for its working. So and second thing, you can notice that the car created the engine object itself, and here we can say that the car creates the engine object itself, and it is a major design problem, or it is a major problem. Why this is a problem? We can see that suppose if the engine changes, then car is affected, and we should change the car also. So here engine is a dependency of car. We can say that engine is the dependency of our car. So what is dependency? Dependency is nothing. When one class depends on another class for its work, then that another class is known as its dependency. So okay, now let's see. Here you can say that the car creating the engine object itself. So it is a major problem. It is a major design problem. Why it is a major design problem? Let's see why this is a bad approach of why it is a bad approach. So what is the problem with this approach, in which the car creating its dependency itself? Car creates its dependency itself. What is the problem in it? Let's see. So you can say that here the car is creating its dependency itself using the new keyword, and here engine is its dependency. Let's see what is the problem in this approach. So first, there is a tight coupling between the car and the engine. That is, car is tightly bound to engine. If something in the engine changes, then we must change our car object. Let's see what is tight coupling. When one class depend on another class heavily depend. Now there is two classes are said to be tightly coupled. If one class depend heavily on the another class, then there is said to be the tight coupling between these two classes. So okay, there is a tight coupling between these two classes, then why there is an issue with the tight coupling? So what are the issues with the tight coupling? So first issue is that if there is a tight coupling between the classes, then this is very hard to change the implementation, and the class is not reusable. Suppose we want to change the engine with the petrol engine, then we need to change here in the class also, and the car cannot be, and the class is not reusable for different types of engines, and it is also very difficult to test. So if we do any changes in one class, then these changes spread across the code bases if there is a tight coupling among the classes. So that's why the tight coupling is a major issue. Why there is a major issue? Because if two classes are heavily dependent on each other, so suppose we changes one class, suppose we change the engine from we want to change the engine to the petrol engine, then we need to change in the car class also, that is creating its object itself. So we need to change it. So one changes in the change in one single class is spread across the code bases. So this is the problem with the tight coupling. So this is the problem with the tight coupling. Then okay, this is a major problem. Then how we can solve this issue of the tight coupling? So there are two methods to solve the problem of the tight coupling. So first say, what happened if we want diesel engine? Suppose let's see with the help of example why there is an issue with the tight coupling. Suppose earlier we have an engine class, now we want the engine, a diesel engine. So diesel engine or petrol engine. Suppose currently the car is using the engine, but suppose we want to change it with the petrol engine or diesel engine. Suppose we want to change it with the diesel engine, then what we need to do? So first we will add the new class diesel engine, and in the car class we will change this, we will cut this line, and we will write here diesel engine is equals to new diesel engine. So we changes the implementation in one class, then this changes spread to the across the code bases. So this is an example of tight coupling, and this is a very undesirable design pattern. So you can see that if we changes the engine to the diesel engine, then we must change the car class also and must recompile and retest it. So this is a very bad design. So tight coupling leads to a very bad design, because if there is changes in the one part of the code base, then this changes spread across the entire code bases. So what is the, then let's say it with the help of an example. So there's an idea. Let's create the new project, and let's Maven with the help of, suppose you have Java, then choose Maven architecture, because in the later of this video we will be adding the Spring context, and let's its name to the Spring, let's name it to the Dependency Injection, and archetype choose to quick start. Let's create it. Okay, we'll give this hyphen. Let's open this windows only. So first let's create a class known as car, and in the car class the car class needs the engine object for its working. So let's first create the engine class, and let's create the engine class in this file only, so that it will be easier to see it. So let's create in class engine, and let's create a method void start. And let's say there is one method start, and this write the engine started. And since the car depend on the engine class, so engine is the dependency of the car. So in the first approach we create the engine object directly inside the car class, and let's see how we can do it. Engine is equals to new car, no sorry, new engine, and let's create one method known as void start, and here we will use engine dot start. First we will start the engine, and then we will print car is started, and then come to the app instance, and let's here we will create the instance of the car. C is equals to new car, and let's see dot drive. Let's see what is the output. Sorry, let's name the method to drive. So C dot, let's see what is the output. So now currently engine is started and car is started, so it's working fine. So basically we have a car class, and here we have engine class, and we can say that the car class is dependent on the engine class. So engine is the dependency of the car, and here the car itself is creating its dependency, that is the engine class. So there is a tight coupling between the car class, between the car and the engine. So why the tight coupling is a major issue? Because let's say now we want to change the implementation, and we want to use the diesel engine. Let's say we want to use the diesel engine, and in this we will write void start and SOUT diesel engine start, and we want to change the implementation from the engine to the diesel engine. Then what we need to do? First we add the diesel engine class, and then we have to come to the car class and also change its implementation. So first we need to come here, and we will have to write the diesel engine, diesel engine is equals to new diesel engine, and then we have to come here and change the implementation diesel engine. So now if we run it, then now it's working. Diesel engine started and car is started. So have you seen that if the car is creating dependency itself, then if we want to change the implementation, then we need to come to that class and change dependency. So if there is change in one part of the code, then this changes is spread across the entire code base. So this is a very bad design pattern. So this is a very bad design, because if we want to change the implementation, then we have to change to several other places. So but we want that if we want to change the implementation, then we don't need to touch the other class. This is known as the loose coupling, and we want to achieve the loose coupling between the classes. So how we can achieve the loose coupling? So how we can improve this design, or how we can achieve the loose coupling between the classes? So there are two methods for improving the design. First, use the dependency injection, and what does it focus? So how we can achieve the loose coupling in our classes? So use the dependency injection. It focus on the reduce, how to get it, and second one is the introduce abstraction. We will see the abstraction in the next video. In current video we have focus of dependency injection. So what does dependency injection? It reduces how to get it. Currently you can say that the car itself managing how to get it, but with the help of dependency injection we will reduce this how to get it. The class does not care about how to get it, it only gets. Let's understand what is the dependency injection. So a dependency injection is nothing. Suppose giving an object its dependencies from the outside instead of creating them itself. So you can see from the definition itself, dependency and injection. Injection means like giving something from the outside. So what is giving from the outside? So dependency, in the dependency injection, the dependency is injected or given from outside the class. So giving an object its dependency from outside instead of creating them itself is known as the dependency injection. So currently what happening here is that our car class itself creating its dependency. So how we can improve this design? So in order to improve this design, so when we use the dependency injection, what we will do, the object, now the class will receive its dependency from the outside instead of creating them itself. So let's suppose we have one private dependency known as private engine dependencies, and now the car itself is not creating this dependency, it will receive it from the outside. So how will it receive it? So there are several methods. Suppose it receives it from through the constructor engine, and it will this dot engine is equals to engine. So and now let's say engine dot start. So now you can see that the car itself is not creating the dependencies, it is receiving it from the outside through the help of the constructor. So now the car itself is not creating the dependencies, it is receiving it from the outside. Let's see how it can receive it from the outside. So what we will do, we will come here and we will write new engine, and now in the constructor of the car we will pass this engine object. So now the car is dependent on the engine, car is depending on the engine, so engine is its dependency, and now the car itself is not creating its dependency, it is receiving it from the outside of the class, outside of the car class with the help of the constructor. So and let's say it's so now, so this is the dependency injection. Dependency is injected into the class through the outside. So this is mean by the dependency injection. So what is dependency injection? Giving an object its dependency from the outside instead of creating them itself is known as dependency injection. So what we have done, so basically the car here we have created one constructor and the object is receiving its dependency from the outside. We can here the object does not create its dependency itself, but it is receiving it from the outside with the help of the constructor and set its dependency through the help of the constructor. So this is the example of the dependency injection. So we have done it with the help of the constructor, but we can also implement this dependency injection with the help of the methods. So how we can implement it with the help of method? Let's see. So instead of with the help of the constructor, let's say there is one method that, suppose we have implemented one method like public void set engine, and here engine, and this dot engine is equals to engine. So and in the app what we will do, here we will create its new and we will set this c dot set engine, and here we will pass the engine. So this is second method of the dependency injection with the help of the setter methods. So basically what we are doing, we have created a dependency from the outside and we are injecting this dependency with the help of the method, setter method. So this method is known as setter method injection. So you can see that it is also example of dependency injection. Why? Because the dependency is injected into the car object through the outside and the car itself is not creating its dependency. So this is the whole idea of the dependency injection. So what is dependency injection? When a class does not create its dependency itself, rather than it receives it from the outside of its class instead of creating them itself. So what is dependency injection? Here the car should receive the engine object, not create it. And so this is the example of dependency injection in the plain Java example. So this is the example of dependency injection in plain Java. So in one line we can say that dependency injection is like, it's a saying that don't create what you need, receive it. So how it can receive it? With the help of constructor injection, or second with the help of setter method. So what is dependency injection? Don't receive, don't create what you need, receive it. So now we will learn about the dependency injection in the Spring framework. So now we have learned about what is the mean by the dependency injection and how dependency injection is happened in the plain Java example. Now we will learn how the dependency injection it happen in the Spring framework, because in the Spring there is a Spring context, and we don't create the object itself using the new keyword. Then how we can inject the dependencies into another bean with the help of the Spring context, because all the object in the Spring framework is stored in the Spring context, and if we want to inject the dependency from into the another bean, then we need to use with the help of the Spring context. So in this part we will see what are the methods and how we can do the dependency injection in the Spring framework. So Spring makes the dependency injection automatic. So Spring makes the dependency injection automatic using its Spring context or IOC. Spring context is also known as the IOC container because it provides the inversion of control. What does inversion of control mean? That the code itself does not control the execution of the program, rather another software known as the Spring framework control its execution. What is meant by the controlling the execution? That is, it created the object and called the other method. So it is the example of the inversion of control. So Spring dependency injection, Spring make the dependency injection automatic using the Spring context or IOC container. So how we can implement the dependency injection in the Spring framework? So Spring provides the multiple ways to implement the dependency injection. So how we can implement the dependency injection is in the Spring framework? So it provides multiple ways. There are basically two methods of implementing the dependency injection in Spring framework. First one is the wiring. This is also known as manual method, and second one is known as the auto wiring. In this, it is an automatic method. Spring automatically inject the dependency when we use the auto wired annotation. So what are the examples, different ways of implementing the dependency injection in the Spring framework? So there are basically two ways. This is the one way and this is a two way. This is known as the wiring and this is known as the auto wiring. So in the wiring method, we have two ways to implement the dependency injection using the bean method call or using the bean parameters. And it is also known as configuration time dependency injection. It is also known as method parameter dependency injection. And second type is the auto wiring, where we instruct the Spring to inject the dependency using the auto wired notation. So this is of three types: constructor dependency injection, setter dependency injection, and the field dependency injection. So let's see each of one in the great detail. So first let's start with the wiring or the manual method of dependency injection. So first let's say how we can inject the dependency using the direct bean method call. How we can inject the dependency using the bean method call. So so how we can do this? So in order to do this, first we need to create the bean, as we have already seen in the previous class, like how to add the bean to the Spring context. So first we will need to create a bean, because dependency is nothing but it is an object instance, so it must be created, and then Spring, all the object creation is handled by the Spring framework. So this object or dependency must exist in the Spring context. So first we need to create the beans. first we will need to create all the beans, and second we need to establish a relationship between them. So basically we have two class. First one we have a car class, and second one we have engine class. And we engine is the dependency of the car class. So first of all, both these beans must exist in the Spring context, and this engine instance provided to the Spring framework, then to the car class then. So first we will need to create the bean of both these classes. So in the previous video we have seen how we can create the instance of bean of these two classes. So let's do a quick example setup. So first we need to come to the POM example and add our Spring context dependencies. So let's add it dependencies, and here we will add org.spring framework, and here it is not the Spring beans, here it is Spring context, Spring context, and the version is correct. Let's reload it. Now it's got reloaded. Now we come to here, and basically currently we are creating the dependency and passing it. So let's hide it. We will not do like this. How we can do? So first we will, so what we need to do, without the Spring framework we are creating the object, but with the Spring framework, our Spring framework handle the creation of the object. So first we will need to create the context, new annotation, config application context, and here we need to pass our configuration class. So let's first create our configuration class, so Java class, and let's name it to the project config. So, and as we have already learned about the previous class how we can create the configuration class. So first we will come here and we will write here configuration, and so how many number, what are the so we have two, you can say that we have two objects that we need to create, that is we have two beans. So we need to create the two beans, so we are creating with the help of bean annotations. So because these two wiring method is of the @bean annotation, we can use it only in the @bean annotation, this method of the wiring. So let's say how we can. So first we will need to create our bean, and first we will need to create the dependency bean engine, and here let's return new engine, and second we need to create the bean of our car. Let's say car C1 is equals to new car, and now car C1 dot set engine, and return C1. So here we are adding the bean to the Spring context. Here what we are doing, here we are adding the bean to the Spring context, and we are establishing the relationship between the beans manually. So in this we are passing the dependency, the object that creates dependency manually, by come here and pass the engine object. So this is the example of using this method. So what we are doing, so first we have created our Spring context, and why, so let's convert it. So we have created our engine bean, and we have created the car engine, and we are giving here, you can say that we are injecting the dependency into our car class through the outside. So it is also example of dependency injection, and we are doing it with the help of the bean. So therefore it is known as bean method call, because we are calling the method setter method, and here we are passing the dependency manually, and therefore it is also known as manual. So let's see whether it's working or not. So so instead of creating the bean with itself, what we will do, we will get the bean from the context. The context dot get bean. And what is the how, as we have already learned how we can get the bean from the context. And let's say whether it's work. Now we don't need to pass the dependency here because the dependency is itself injected through during the bean creation. Let's only see dot drive, and let's see whether it's working or not. Okay, okay, it's getting error because we haven't passed our project config.class because it needed configuration class. Let's run it now. So now you can see that it's working fine because what is happening here. So let's understand how we can inject the dependency using the so so let's see here what's happening here. So what we are doing, first we have created our engine. First we have our created the dependency bean. Second we have created our bean, and in the set engine we have given the engine the method that is returning the dependency bean, and we are calling this method from the we are passing it from the outside, therefore it is an example of dependency injection. So what happened, spring first intercept the engine call, and spring return the bean from the context, and spring supply the dependency externals, therefore it is an example of dependency injection. So let's see what is happening here. So first spring, so what in the step one, what's happened in the step one, let's say what happened. So first the engine bean is created and added to the spring context. Let's say, so let's say in the first step the engine bean is created and added to the spring context. In the second example, what is happening in the second example, in the second step, the car dependency is car bean is created, it is the car, and here is the engine. And when we call the engine, so this engine is injected into this as a dependencies. So it has an engine field, and this engine field gets set to here. Therefore it is, so now car engine is injected into the car. Now you will be wondering, like, when we call the engine method, is the second two instance of the engine exist in the spring context? So that answer is no. Spring is very smart. So when it call the engine, when we call the engine method, so spring intercept the engine call and check if the engine bean is present in our context. If the engine bean is present in our context, then it returns it directly without creating another instance. But if suppose if the engine is not exist in our spring context, then only spring will create the engine bean. So basically we have only one instance of both spring, one instance of car and one instance of engine. So when, so engine does not create the new dependency, engine dependency. If suppose when we call the when we have called the engine method, so what's happening, so spring first check in the spring context is if the engine dependency exists or not. So if the engine dependency exists, then it directly return the engine dependency from the context. But if the engine dependency, engine bean does not exist in the spring context, then only it create the new bean. So we can prove this with the help of example. Let's come here. In the car, let's add one constructor to our engine here, engine, and let's see how many times it is creating. Let's add one constructor. So basically whenever it's called, whenever it is created, this will be called. Let's here engine created, and let's say here. So So if the engine is created 2 times, then the engine is created will be printed 2 times. But if it is created 1 time, it will be printed 1 time only. Let's see how many engine instances created. So as here you can say that engine created is printed only 1 time. So that means that the engine dependency, engine bean is created only 1 time. So what happened? So the spring will intercept this engine method called and. So this is very simple. When we call the engine method, let's first clear the screen. So this is very simple. When we call the engine method, so spring intercept this call is engine bean exist in spring context. If engine context, if it exists, directly return that bean. But if engine is not, if the engine dependency is not present in the spring context, then first create it and then return it. So this is the whole architecture. So what's happening here? So first spring will create the context and then go to the configuration class. First it see the bean method, it creates this bean and add it to the spring context. Second, it see this method is also bean, so it run this method and add the car bean to the spring context, and it injected the dependency from the outside, and there is only one instance of the engine exist in the context. So this method call does not get the multiple instance of the engine dependency. There is only one instance of the engine dependency, and it is injected by the spring framework in our car class. So this is first method and so this is the first method of the dependency injection using the direct bean method call. And here what we are doing, we are calling the bean method directly. So this is the first method. Second method, as the name signifies, using the bean method parameter. So let's see how we can do the dependency injection in the second method. So using the bean method parameter. So here what we are doing, we are calling the method in the first method. So this is bean method. So basically what we will do here, we will add the dependent, we will in this method we create here and we do this, and suppose we can name it anything, like let's only name it E, and we will set E here. So what's happening here? So this is the second method of dependency injection using the wiring method. So let's see whether it's working or not. So here, as you can see, it's working. Dependency get injected into our class. So basically engine is created and car started is printed from here car only, because it called this method engine dot start, and it is engine created is printed by the car. So this is the second method of the dependency injection using the bean method. So now you will be wondering, like, how, from where does this dependency is injected into this E? Where does the dependency E come from where? So let's see. So what we are doing, so here we are passing the dependency using the method parameter. So what is the flow? So in injection explicit, spring supply the dependency. So from where does here come the dependencies? So here the spring supplies the dependency. So from where does this dependency come? So spring supplies these dependencies via the method arguments, via method arguments, and this is cleaner and more flexible. Let's say the whole flow. So first spring create the context using, when we write the where context. So spring created the context, then it go to the configuration class, because in the context we have specified our configuration class. It go to that configuration class. In that configuration class, it see all the method that is annotated with the bean annotations, and it runs all these methods. So first it see here that here the engine is annotated with the bean. So what will happen here? So first the engine is created and added to the spring context. So here is our spring context, engine dependency is created into it, engine is injected into it. So second, now the spring come here and it's see that here there is a class car, and in the method argument it sees that there is one dependency of it like engine. So what the spring does is spring from the spring context inject the dependency into this parameter, from the spring context add this dependency into this parameter. So now after, and then it created the new instance and we set the dependency using the setter method and we return c1, we return the c1. So now this instance is added to the spring context of the car. So have you understand it, how the whole flow? So what's happening here? So first it see the bean method annotated with the bean engine, it created its bean and added to the context, and then it added to the context, and when it see the go to the second car bean, it say that in its method argument there is a one engine bean that is specified. So spring understand that the car, for the creation of the car bean there is a dependency, needed dependency of the engine bean. So spring automatically inject the dependencies through the in the this engine parameter. So now you will be wondering what happened if the engine is after the bean, like so what happened if the this engine object is after the bean or bean? So basically, so in that case, so first it will come here and it will see that the car is dependent on the engine. So spring will first create the engine bean and add it to the context and then inject this dependency into here. Let's see with the help of example what happened if the engine is after the bean. So it does not affect anything. Let's run it. So it does not affect, it is not affecting anything because first spring come here and see that the car in the method argument, see that the car is the, for the creation of the car bean it needs to create the engine, because car engine is the dependency of the car. So first it searches the bean of the type engine, create, call this method, add it to the spring context, and then return its instance, inject it into the e parameter, and now we can directly inject this dependency using the method parameter. So this is the second method of the bean, second method of the dependency injection in the string, and this is also known as wiring because it is manual, so this is known as wiring because here you can see that in the both the method we are manually establishing the relationship with the help of the setter method. Here also you can see that we are establishing the relationship with the help of the setter method. So it is a manual method of dependency injection, therefore it is also known as wiring. And next we will learn about, so there are two methods, one is the bean method call and second one is the bean method parameter. So these are the two methods of the wiring method, wiring dependency injection. Next we will learn about the auto wiring annotations. So now we will learn about dependency injection via auto wiring. So as the name signifies, auto wiring, that is the dependency injection is automatic. Dependency injection is automatic without any need of establishing the manual relationship with it. And it is a stereotype annotation method. And it does not work in our bean annotation. It does not work with the bean annotation. Auto wiring only work with the stereotype annotation like component, service, repository. And if we want to do it with the help of bean, we can't do it. So let's see what. So Using the auto-wired annotation, we mark an object property where we want the spring to inject a value from the context. So basically using the auto-wired annotation, we instruct. So annotation is nothing but the metadata. It provides information to the spring context. So auto-wired provides the information to the spring context like, hey spring, add add this value from the spring context. Let's say with the help of example. So first we will see how many types of dependency injection via auto wiring. So there are three types. First one is the constructor injection using with the help of constructor. Second one is the setter injection with the help of the setter method, and third one is the field injection. So with the help of auto wiring, there are three methods of the dependency injection. First one is the constructor injection, second one is the setter injection, and third one is the field injection. So let's study each of them step by step. So what does the constructor injection mean? So in the constructor injection, dependencies are provided through the constructor. Let's see what is in the constructor injection. Using the auto-wired annotation, we mark the constructor with the help of auto-while, like, hey spring, add the dependencies here in the constructor. So using the auto-wired annotation, dependencies are provided through the constructor. Let's say with the help of example. So it is a stereotype annotation. We don't need to create like this. Comment out this all, and we come to our car class, and here we will create the constructor, and let's hide this method for a while. And here we have constructor, and the dependency is injected with the help of the constructor. So before here we will write auto-wired. So what it will does, the spring, and we will mark this with the, so we will mark it with the help of component, because, and second we also need to add the engine. First remove it, there is no need of this. We will see it in the abstraction video in the next video. And we will also mark it component because we instruct the spring to create its being in the spring context. Now we mark it here auto-wired. So what does it mean? So it means that spring come here, and first, and we also need to add here component scan class, component scan, and here we will write base packages is equals to what is our package name. From here you can see that here is org.example, org.example, and let's run the app and let's see what happened. So now it's working, dependency is injected into it. So how does the dependency is injecting? So first spring, so let's see from whole now. First it come here context, and it see that okay, we spring created a new context using this method and with the help of this class. So what happened, it comes to this class, and here it see the component is okay, so springs using this line, spring go to org.example and find all the classes that are marked with stereotype annotations. So it come to the car class, these two beans are annotated with the stereotype annotation. So it come here and created the engine bean and the car bean. So during first it create, so after creating it, when it comes to for the creating of the car bean, it's C, so it call its constructor. So because bean is created, so because any new object is created using the constructors, it comes and call the constructor, and it see that here the spring see the auto-wired annotation. So it understand that it need to provide this dependency from the spring context. The spring provide this bean from the spring context, and now the dependency is injected into it. As we can see, the code is running fine. So what happened in the constructor injection? The dependency are provided to the constructor. So we can see that here the dependency engine is a dependency of the car class, and this dependencies is provided through the constructor with the help of the spring. So this is the example of constructor injection. We can say here the auto-wired annotation, this it instructs the spring to add this dependency from the spring context, add the dependency from the spring context. Let's see the whole flow. Let's see the whole flow of the dependency injection. How does this dependency injection is happening? The whole flow. So first, what happened? So what happened here? So first application is started. When we start the application, so what happened? So first application is started and the context is created. So during the context, so first one is a component is scanned. Why component is scanned? Because here we in the component scan we have written the component scan, and it find all the component or all the class that are marked with the annotations. So basically we have two components that are marked with the component car and engine. So it identified that we have two class car and engine component. We have two beans that are marked with a component and need to create its bean and add to the Spring context. So now the bean creation phase starts. Now, so let's say first the Spring tries to create the car bean. Currently the Spring context is empty. Spring context is empty, and now Spring tries to create the car. So Spring tries to create the car bean. So because of how the Spring can create the car bean using the new method, but when it is going to call the new car, Spring realized that okay, Spring Spring immediately knows that car cannot be created without engine. Why? Because any object is created with the help of the constructor when we call the new and with the help of constructor. So when it come here, the constructor, it saw that okay, there need to be parameter. Here is a parameter engine, and this engine should be provided, and it cannot be null. So Spring immediately know car cannot be created without the engine. So it is the dependency detection phase. So Spring identified that okay, car is dependent on the engine. So what happened now? Now it resolved the constructor dependencies. So first it identified that the car cannot be created without the engine. So now the dependencies is resolved. And so how is dependency resolved? The Spring asks from the context. So here we have context. So what is here? Here we have context, and currently the context is empty. The Spring asks, do I already have an engine bean? So here the answer will be no, I don't have the engine bean. So what happened? No. So what happened? So first it create the engine. So now engine, it will first create the engine. So since engine does not depend on any other bean, so engine is created and added to the Spring context. So now in the step, this engine is added to the Spring context. Next, dependency is created. Engine dependency is created. Now this engine dependency is now injected into the constructor. Now you can say now. So after the engine is created, this is injected into where the constructor, and now car bean is created. Now car bean is also created. Car bean is also created, and its dependency engine is injected. Its dependency is injected using the constructor, and now the car is now ready to use. So from here to here, there is a dependency injection part. First Spring tries to create the car, but with the help of the constructor injection, there is an, because we need to call the constructor for the creation of new instance. So Spring call the constructor, but when it tries to call, it sees that okay, the car is dependent on the engine. So first it resolves the dependency. So for Spring first asks, do I have engine dependency? So no. So first it will create the engine dependency, and since the engine does not depend on any other, since engine does not have any dependency, so engine is created first and added to the Spring context. Now engine is returned, engine is passed via the constructor, and now the car bean is created, and now the car is ready to use. So this is the whole flow of the constructor injection. This is the whole flow of the constructor injection, and the constructor injection is recommended, and it is the best due to the following reasons. First, so the constructor injection is the best among all the other type of the injection, and it has several advantages over the other. So for what are the advantages? So first, there is a fully initialized object in the constructor injection. There is a fully initialized object because car is not ready to use until and unless engine dependency is not is satisfied. So fully, there is a fully initialized object, like when the car cannot be created, the car instance cannot be created without the engine dependency. So a car can only be created when there is an engine available. So in this case, there is fully initialized object, there is no partial initialized object. We will see that what does mean by the partial initialized object in setter and the field injection. And there is also compile time safety, because if there is any error in the if the dependency is missing or dependency not found, we will know this error at the compile time only, because with the help of constructor injection. And here we can also achieve the immutability. For example, once we can use here final keyword, so after initialization, this engine dependency cannot be changed or changed. So we can achieve the immutability, and this is preferable, because in the multi-threaded environment, if multiple thread complete for this reason and try to change it, then there can be more than one change. But with the help of immutability, it guarantees that once the dependency is created, it cannot be changed. So these are the some of the advantages of the constructor injection. There is a fully initialized object, compile time safety, and immutability. Let's see the another. So let's see the advantages in detail. So it guarantees the fully initialized object, because spring cannot create the car without the engine. No partially created object, no null dependencies. Object is valid because the object is valid from the moment it exists. There is no case like the engine is null for any moment. The engine dependency is not null for any given moment, any moment. So the car is valid from the moment it exists. Now, what happens if the dependency is missing? Second advantage and the third advantage. So what is the third advantage? That it ensures the compile time safety. What is dependency is missing? It gives the compile time error and the bug is detected early. It prevents us from the runtime error, and it also ensures the immutability. Like once the engine is created, then it cannot be changed, because we can use here final keyword. Because once we use the final keyword, then it must be initialized here only, or it should be initialized with the help of the constructor. So it is initialized using the constructor, therefore we can use the final keyword here. So it guarantees the immutability. Let's see about the field injection. What is the field injection? Let's study about the field injection. As from the name signifies, that it means that the spring injects the dependencies directly into the class fields, bypassing constructor and setter. So what is meant by the field injection? From the field injection, it signifies that spring inject the dependencies directly into the class fields. So what does mean by the field injection? The spring directly inject the dependency into the class field by passing the constructor and the setters. Let's see it with the help of an example. So here we have our car class, and currently it is injected using the constructor injection. Let's comment this out. We can use the final, and it guarantees the immutability, because we are initializing with the help of constructor. But let's see, if we don't initialize with the help of constructor, it will give us error, because it need to be initialized. So now let's see what is meant by the field injection. So using the field injection, first we will need to remove this from here. Now with the above the method, we need to write the auto wired non annotation. So this is the field injection. So what does spin does? Spin directly inject the dependency into the class field without any constructor or dependencies. Let's run it and see whether it's working or not. Now it's working. So it is an example of field injection. We using the auto add annotation, we mark the class field where we want the string to inject the dependencies. So this is an example of field injection because here it is a class field and a dependency is injected directly into the field. Therefore, it is an example of the field injection. Because here we have write the auto add annotation above the field, and so the spring inject the dependency into this field. Let's see how does the field injection work. Let's see the complete flow of the field injection and what are its several disadvantages. So yeah, so first step is the first step remains the same. First is application start and the spring context is created. Currently the spring context, so first the spring context is created, and currently it is empty. Second, component, so first application start. So here from component scan and it identify all the component, in the com.example. There are two components. First one is the engine and second one is the car. Next, now the bin creation phase start. It identified that there are two bins. First one is the car and second one is the engine. It identified there are two bins, car and engine. Now the bin creation phase start. Spring tries to create the car. So how does the new instance of the any object is created? Using calling a new car. So new car. So Spring create the car object using new car. Now Spring create, because here the new instance of the bin can be created because there is no dependencies, because new instance is created with the help of the constructor, and here there is no constructor defined, so there is a default constructor. So the new car is created here. So new car is created and currently the engine is null because we haven't initialized the engine, and therefore currently the engine is null. And here what we can say that here we have car bin is created but its engine property is currently null. So currently the car dot engine is equal to null. Car exists in the broken or incomplete state because engine is the required dependency, but with the help of the field injection the car is created first without the dependency, and for the this moment engine is currently null and this is not required for currently. If we using during this phase, if we call car c1 dot drive, so engine will be null, and when we write engine dot start it will give the runtime error. Why? Let's see. Currently the car instance is created but injection dependency is not injected at this point. Currently the engine is null, and when we type engine dot start at this moment only, if we trigger the car dot start it will call the engine dot start. Since the engine is null and we try to call the method, so it will give us the null pointer exception. So the car exists in the broken or incomplete state. So after the car is created, now the dependency is resolved after the creation of the object. So Spring will so after the car is created, now it will process all the field that is marked with auto add annotations. So it identified, okay, this field is marked with the auto add annotation. So Spring asks, now the Spring asks, do I already have an engine? So Spring identified that it is marked with the auto add annotation, and Spring need to inject the dependency into it. So first Spring will ask from the context whether do I have an engine bin. So if yes, if it replied yes, then it directly inject it into here. But if it answer no, so what will happen? First it will create the engine and add it to the add it to the context, and then create the engine first and store it in context, and then inject the dependencies where the reflection after the object creation, and then inject dependency into this field, and now the engine is not null and it point to the engine. So now car is now finally ready to use. So you can see here that for a moment car is exist in the incomplete or broken state using the field injection, because injection is happening after the creation of the object. After the object creation, injection is happening. So this will be error. We can see this example with the help of, let's say, uh, let's define one constructor, empty constructor, because it is created with the help of the constructor only, and let's try to run here. It will give us the null pointer exception. You can see here. Now if we run it, now the spring will first create the, using the field injection, we are using here the field injection. So first spring will first create the car object, and then after creating it, it will inject the dependencies. So it should give us the null pointer exception. You can see here. Here you can see here we are getting that. Here you can see cannot invoke yg.example. Because this dot engine is null, because currently first what in the field injection, first it will create the bean. So using new constructor, and it is calling the creating the bean, but during the creation it's currently the engine is null and it's calling engine dot start, therefore it is giving here the null pointers exception. Here you can see that null pointer exception. So why? Because for the moment of creation, because in the field injection the dependency is injected after the object creation, but here during the object creation only we are calling engine dot start, and at this moment engine is null, therefore we are getting the null pointer exception in this case. So now let's say what are several disadvantages of it. So here we are no fully initialized object exists, no compile time safety, give runtime error dependent. So we have seen that using the field injection, the object is available for us within the broken or incomplete state. So there is no fully initialized object, and also there is no compile time safety, give runtime error if the dependency is missing, and we cannot, oh sorry, it is not, it is constructor example. Here it is auto add, and we cannot use the final keyword here, because if we use the final keyword, then either we have to initialize it here or using the constructor injection, but therefore we cannot use the final keyword here, therefore it is mutable. So if multiple thread work on it, then it can be mutated. So dependencies is mutable. So these are the several disadvantages of the, and also can't use final keyword, dependency can change after creation, and there is a hard to test it. And dependency is also hidden. By looking at the class method and its public API, we cannot tell that because car can be created directly like this. So and there is not any setter method for the dependencies. So we cannot understand that there is some dependencies in. So there is a hidden dependencies using the field injection. So that's why we should never use the field injection in our code, because it has several disadvantages. Object exists in partial or uninitialized object, and also the dependency is mutable, and dependency is invisible or in hidden dependencies. So these are the several disadvantages of the field injection. Next we will learn about the setter injection. So what happened in the setter injection, as from the name signifies, what is happen in the setter injection? So dependencies are injected through the public setter method. So in the setter injection, the dependencies are injected through the public setter method. Let's say it with the help of example. Let's delete all this, and let's So what happened? Let's here private engine, and let's, so what does mean by the setter injection? So there is a public setter, a public void set engine, and here we will write engine, and here we will write this dot engine is equals to engine. Now currently, and we mark it here with the auto add annotation for providing the dependency into it using the Spring context. So now if we run it, let's see what happens. So now it's working, but so here, so here what we are doing, we are injecting the dependency using the public setter method. Therefore it is an example of the setter injection, and let's see the whole flow how it's working. And let's say if we remove it from the here, there is no dependency injection and it will give us the error. So using the auto add annotation, we are instructing the Spring to inject the dependency into it, and then the dependency is set. So unlike constructor injection which happened at the moment of creation, now in setter injection is also like field injection. Setter injection also happen after the object creation. Setter injection also happen after the object creation, not at the moment of. So unlike constructor injection which happened at the moment of creation, in the constructor injection happen at the moment of creation only, but in the setter and the field injection the dependency is injected after the creation of the object, after the object is created. Let's say in the whole example how does the setter injection work. So here we created one public method that set the engine setter method, and we marked with the auto add annotation to instruct the Spring to inject the dependencies into it. Now let's see how it's happening in the complete detail. One public method, we have one public method that set the dependencies, and we mark it with the auto add annotation and instruct the Spring to inject the dependency into this engine, and we are setting it with the help of here this dot engine is equals to engine. So what happened initially in the Spring start, what happened first, the application will start, and currently the Spring context is empty. Context is empty. So first it will start scanning the component and find that we have the two component, car and engine. Now Spring tries to create the car, and since there is not any constructor defined, it called the default constructor new car, and since there is no dependencies into it, therefore car can be created easily. Spring creates the car using the new car, and at this instance the car is created and added to the context. And currently the engine is equal to null only. Engine is null because currently dependency is not injected. And currently the engine is equal to null. Because dependency is not injected at this point. So car dot engine is equal to null. Car exists in broken or incomplete state as that was in the field injection. In this also the object can be created without the dependencies. And there is a object existing and broken on the incomplete state. Now after the object is created, then the dependency resolution happens. Process the auto add method. Now after the dependency is created and added to the bean, the bean is added to the Spring context. Now the Spring will process all the method that is marked with the auto add annotations, and it sees that here in the method parameter there is one dependency of the type engine. So it will ask, do I have an engine bean? So if the engine bin exists, then it is directly injected, but currently there is no engine bin. So first it will create the engine dependency and store it in the context. So now engine is created and added to the Spring context, and after that this engine is injected into this class inject dependency via the public setter method. It will call this public setter method and pass the dependencies into it and set the engine using this method. So car is now finally ready to use. So we can see here that car existed before it was ready. We can say that the car is created here, but its dependency is not meet here, like engine is its dependency and it is not meet here. So we can say that car existed before it was ready. So what are its disadvantages? Its disadvantages are same as the field injection: no fully initialized object, no compile time safety, dependency isn't mutable because we cannot use the unlike the constructor injection, we can use the final keyword here because we are initializing the engine in the constructor, but in the public setter method we cannot use the final keyword here because, as you already know, if we use the final keyword, then it either need to be initialized here only or in the constructor, but there is no constructor and we cannot initialize it here, therefore we cannot use the final method. Therefore it is immutable. It is mutable. It can be created, can use the final key, dependency can change after the creation, and it is hard to test. And there is partial visible dependency because the object can be created without the dependency and there is no dependency specified in the constructor, therefore it is not truly visible. It is partially visible because there is a setter method for setting it, but in case of field injection it is fully visible, invisible or hidden. So now let's see. Now we have learned all the three method of dependency injection in the Spring. Now let's see what are the difference between these all. What are the difference between all these? So let's see. Constructor versus field versus setter injection. So first aspect, fully initialized object. So in the constructor injection, yes, we have fully initialized object because object cannot be created without the dependencies, because in the constructor only we have marked that our dependency engine. So Spring first need to create the dependencies, then it can create the car object. But in the setter and the field injection, object can be created without the dependency, and object this can be not fully initialized object, and engine can be null in this case. Now since it provide the compile time safety, because if the dependency is missing it can be added and therefore car cannot be created, and it gives us the compile time error. But in case of field and setter injection, there is no compile time safety and we will get more runtime error, as because when we write engine dot start, compiler will not give us error because it cannot see that the engine is null. In constructor injection there is immutability, but in the setter injection there is no immutability and or mutable. The dependency is mutable after the creation in the setter and the field injection. Now in the constructor injection, dependency is visible because in the constructor only we have defined our dependency. In the setter there is a partial visibility, but in the field injection dependency is completely hidden because there is not any dependency in the constructor, and there is also not any setter method that sets this dependency. Therefore in this field injection the dependency is completely hidden. So constructor dependency cannot be used for the optional dependencies. It can be used for the optional dependency, yes, because so constructor injection cannot be used for the optional dependencies. Setter injection can be used for the optional dependency, but field injection is very risky. It is testability wise. Dependency constructor injection is easy, setter injection is okay, but field injection is very hard to test. So these are the some of the difference between the constructor, field and the setter injection. So we have covered our dependency injection, the different method of dependency injection. Let's see some of the major pitfalls or some common errors in the dependency injection. So first one is the circular dependency. By mistakenly, we created some circular dependency and it gives us some error on how to avoid circular dependency. And what happens if more than one bean of the same type are available in the Spring context, then how Spring will decide which bean to inject. So let's first study about the circular dependencies. So circular dependency, what does it mean? So a circular dependency occur when bean A depends on bean B. Suppose we have two beans, bean A and we have another bean B, and bean A depends on another bean B, and bean B also depend on bean A. It also depends on bean A. So there is circular dependency. If Spring goes to create the bean A, then it say that there is a bean B we need to, and when it go to create the bean B, it say that bean A need to create the bean A. So Spring, so now the deadlock situation. The Spring cannot create the bean A without the bean B, and bean B cannot be created without the bean A. So now there is a deadlock situation in here. So Spring is stuck, no bean is created, the application startup failed. So this is the example of dependency injection when bean A depend on bean B and bean B depend on bean A. Bean A B depend on bean A and bean A B depends on bean B. So Spring first go to try to create the bean A. It's okay, it's depend on the bean B. It try to create the bean B. Now it say okay, I need to create the bean A, but it say that I have already creating the bean A. So it give us the error, application startup failed. Let's see. Neither bean can be created first and the Spring is in the deadlock situation and application startup failed. Let's see it with the help of our example. Here we have two classes, engine and the car, and let's create one dependencies into it. Let's say private car, and let's inject it with the help of our constructor injection. Engine, car, and let this dot car is equals to car, and mark the constructor auto for the constructor injection. And also let's use here, and let's say if we run it, then what it will give us. As you can see that it is created, but we have used the circular dependency. Then how it is getting created? Because we haven't used the constructor injection for its creation. So what happened? First it come to the engine and it see that it depend on the car. So it go and create the car instance. Since car instance is using the setter injection, so it can be created without the dependencies. So first it is created, and then once it's created, then it's go to car and supply its dependency here. So that's why it's not giving us error, because we have used here setter injection. But if we use, because in setter injection that object can be created without the dependency, and after the object creation the dependency is injected into it using the public setter methods. But in the constructor injection, the object cannot be created until and unless dependency is provided. So let's say if we use a constructor injection, then it will give us the error. And let's say this dot engine is equals to engine, and let's see now if we run it, it will give us the error. You can see that here we are getting the error, circular dependencies. Here you can see that is there unresolvable circular reference. Because why it is giving the error? Let's see here. Error creating the bean with name car, requested bean is currently in creation. Let's see here we are getting the error creating the bean with car defined in this, because we cannot create. So because there is a circular dependency, we cannot create the dependencies. So this is the example of circular dependency. What is its example? It depend on A and A depend on B, then there is a circular dependency. But we have also seen that the circle, if okay, now how we can avoid the circular dependency. So if there is a circular dependencies in our project, then there is a, and then we should redesign our classes, because our class design is wrong then. And if there is some shared logic, then we should extract that shared logic in the third class and use the unidirectional dependencies, like the dependencies in the one direction, not in the reverse direction. So these are, and don't, using these approaches we can avoid the circular dependencies. So now let's see what are the problem with the multiple beans. So first we have seen about the circular dependency, what is and how we can avoid it. Now let's see about the multiple beans. Sometimes, suppose some cases, sometimes Spring needs to inject a dependencies, but multiple beans of the same type exist in the Spring context. Suppose here is a case. Spring must decide which one to inject. Spring must decide which one to inject. For example, we have in car class, and here is one dependency, engine, and in the context there are three engine available already, then Spring, and here is Spring need to inject one. Then is how Spring will resolve that which engine to inject. For example, consider example, we have three bean of the type engine, and class need an engine dependency. So which engine will Spring inject? Now let's see it with the help of example. Since using for creating the multiple bean of the same type, we must need to use the bean annotation, because using the stereotype annotation we can only create one bean of the same type, only one bean of one type. So we need to use the bean annotations. So let's use it at the rate bean, and let's create the three instance of the engine 1, and let's in order to distinguish between them, let's give it some name here. So basically we have added one name. So what we have added one name so that we can easily identify which engine is created, and we have created one method get name for getting the name, and in a engine we have added one method get engine name for the car. So and let's create the three engine, return, let's say new engine, and let's name it engine 1, and also let's create the two more engine of this type, and let's name it engine 2, engine 3, and engine 3. So now let's see the whole flow, what happened. So basically we have one class in this c dot trial. So, and let's remove this line. So what happened here, we have our component car class, and here the car depend on the engine, and the Spring need to inject the engine dependency into it. But we have created the, in the Spring context there are three bean of the type engine exist. Now there is ambiguity, which engine should the Spring inject. So let's see, because now in what happened here in the Spring context we have three engine, E1, E2, and E3, and Spring tried to create the car class dependent on the engine. Now when it tried to inject the engine, now it see the three engine. Now the Spring will not know which engine to inject into it, and therefore it gives us the error. Let's try to run it. It will give us the error if we try to run it. Now here you can see that we are getting the error. Here you can no qualifying bean of the type engine available, expected single matching bean, but found three, engine 1, engine 2, and engine 3, because Spring is not able to decide out of the multiple. Here we have multiple beans available of the same type, and the car class is dependent on the engine bean, but which engine is to inject, Spring is not able to identify it. Then how Spring can resolve this ambiguity? So let's see how we can resolve this ambiguity. How we can resolve this ambiguity? So using Spring follow a clear priority order. Spring follows a clear priority order. Let's see what are the priority order. First, it matches the parameter name matching. Second is the primary annotation. Third one is the qualifier, and failure if none of them apply. So what is the parameter name matching? So basically what happened when we created the bean? For example, when we created, let's see here we have created the 3 beans. Now bean is created, and it's as in the previous video in the video of the Spring context and bean, I have explained you that the bean gets its name from the method parameters. So when the engine 1 is created, so let's see, when the engine 1 is created and when the engine 2 and engine 3 is created, its name is given of its method name. So it will be named as engine 1, engine 2 and engine 3. So these are the name to the, and it is our context. So what happens? So first, parameter name matching. So during this, so what it mean by the parameter name matching? So if the parameter name matches a bean name, Spring inject that bean. For example, in the car class, we have what we have used. For example, so what is meant by this? For example, in the car class, what we have used here in the parameter name, we have used the engine. But if we use here one of the name of the bean available in the Spring context, then Spring will inject that bean. For example, what we have named, we have engine 1, engine 2, engine 3 name available in our Spring context, and in here in the method parameter we have uses the engine. But if let's see, if we use the engine 1, then the Spring will inject the engine 1 from the bean, and we can see here. Let's run our app and let's see which bean it injected. So basically all the 3 engines are created. Why all the 3 engines are created? Because we have used here. But how we can get car is using which engine? So let's say here in the constructor, in the drive, we write here, let's say car is started using, and here we'll write the engine name, engine get engine name, right here, and let's run it. We can say that car is started using engine 1. So we can get here that, or we can directly write here also engine dot get name, get engine name. There is no need of this method. This is redundant. Remove it and add here engine dot get name. So now run it. So we can see that, and one more. Let's remove this console.log statement from here. So now basically we can or let it remain in here, because engine come here, now Spring see here, and all the 3 beans, all the 3 engines are created and added to the Spring context. All are given the unique name, engine 1, engine 2, engine 3. In our car class, we have used the parameter name. We have used the parameter name to the engine 1 that matches one of the name from here, so that therefore this engine gets injected into it, and we can say that car is started using engine 1. But here if we give it like name to engine 2, and here engine 2, and here also if we give engine 2, and if we run now it will show car is started using the engine 2. Here you can say that car is started using the engine 2. So how it remove the ambiguity? So first order is name based matching. So the parameter name matches, if parameter name matches a bean name, because we have multiple bean available here, And if the parameter name that we are using in the constructor, for example, constructing the constructor, we are using engine, and if we use the engine 1, then this engine will be injected. But if we use engine 2, this will be injected. Yeah, if we use engine 3, this will be injected. So this is the example of the parameter name matching. If there are multiple bean of the same type, then the spring will inject that bean whose name matches with the parameter. So this is the name based matching. Second one is the primary qualifier. So let's say primary qualifier now. Suppose if there is no name match found, suppose we have case 2, suppose we have engine 1, engine 2, engine 3, and in the car if we write, let's say, engine 4, so we have not in the context we have 3 beans having name, having engine 1, engine 2, and engine 3, but in the method parameter we are using the engine 4. So there is no name match found because we are using the engine 4, and in the spring context we have engine 1, engine 2, engine 3. So there is no name match found. Then how it can be resolved? Then using the qualifier, using the primary annotation, we can instruct the bean that by default this bean should be injected. So let's see, if currently if we run this, it will give us an error because there is no matching bean found, because here you can no qualifying bean of type available if 3 available on that found 3 engine 1, engine 2, engine 3. But let's come here and mark the engine 2 as primary bean. Now run it. Now you can see that car is started using engine 2. That is engine, if no name matching found, then this primary bean is injected into our spring context. So here you can see that here we have using engine 4 not matching, then the primary bean is injected. And let's see what happened if the name match found. Suppose engine 1 is matched and we have engine 1 and engine 1 and we have marked the engine 2 as primary. Let's see which one will be injected. Here you can say that engine 2 is injected only, because if multiple bean of the same type exist, then the primary bean is injected into it, because the bean marked with primary will be injected even if the name match found. So, and let's say engine 4 and engine 4. So we can mark one bean as default by using the primary string inject, that we have seen that. Now third one is the using the qualifier. In the method parameter we use qualifier and pass the method name. When we on full, we use qualifier and we will write here our name of the bean. Using the qualifier, if we want, when we want full control, we pass the, before the method parameter you use qualifier, and here we will pass the bean name that we want to inject it from the, context. Let's see it with the help of example. Here we have engine 4 and there is no matching bean found. Let's say we want to inject the engine 3. Then what we will do, we will come here and mark it qualifier, and here we will pass the name engine 3, and let's, engine 3 is the name, engine 3 is the name, and let's run it. Now all the 3 beans, all the 3 engines are created and car started using engine 3. Why engine 3? Because we have explicitly marked engine 3 to be injected. Even if there is primary bean, still the qualifier take the precedent, and that engine is, that bean will be injected whose name will match from this qualifier. So using all the 3 methods, we can resolve the resolve the ambiguity if multiple bean of the same type exist. First using the method parameter name, second one is using marking the primary, and third one using the qualifier. If none of them satisfy, then we will get the error. For example, we can see that if there is no qualifier and if there is no primary bean annotations, and if we, then there is multiple bean of the same type exist, and if we try to, then there will be ambiguity, and the it will give us the error. Spring. So using qualifier we can inject specify a specific means. So this takes us to the end of the video. So in this video we have learned what we have learned in this video. In this video, first we start with what is the dependency. In this video we have learned what is dependencies. Then we learn about what is the dependency injection. Then we learn how dependency injection work in the plain Java. Then we see how the dependency injection work in the Spring and the Spring Boot framework. We learned that there are two methods. First one is the wiring, that is manual. Second one is the auto wiring, in which automatic. In wiring we have learned about the two @bean method call and the @bean method parameter. In the auto wiring we have learned about the three: constructor injection, field injection, and the setter injection. And we have learned that the constructor injection is best and recommended. Then we have learned about the common pitfalls like circular dependencies, why it exists and how we can avoid it. Then we'll learn about what happens if the multiple bin of the same type exist and how we can resolve that dependencies. So this takes us to the end of the video. So in the next video we will learn about, in this video we have learned about the first method of achieving the loose coupling using the dependency injection. Second, in the next video we will learn about second method, that is how we can use the abstraction to achieve the loose coupling and how we can do the dependency injection in the abstraction. So thank you for, so in the next video we will learn about this. Thank you.